A faint whisper of motion at the edge of the solar system had been building for weeks, an anomaly tucked into the background noise of standard survey data. It wasn't unusual for observatories to find something new. Stray comets, dormant fragments, minor interstellar drifters, but this one refused to behave like the others. Its inbound trajectory sharpened with every recalculation, its signal growing in strength rather than dissolving into uncertainty. The object was enormous, far beyond the scale of anything previously detected on a similar path, and each day added new layers of astonishment to the unfolding story. When the observing teams finally confirmed that it was heading straight toward the path of 3I Atlas, the third known interstellar visitor ever catalogued, the scientific world jolted into a level of intensity not seen since the discovery of Oumuamua. 3I Atlas had already been a treasure, as only the third confirmed object from beyond the solar system. Its presence carried enormous significance. Its elongated form and erratic spin had set off discussions about its origins in history. Unlike Oumuamua and 2A/Borisov, Atlas carried a hybrid signature, part comet-like, part asteroid-like, suggesting a life shaped by violent transitions between star systems. Now an object 100 times larger was bearing down on the exact region of space 3I Atlas was moving through. The alignment wasn't casual. The precision was far too remarkable for coincidence. Researchers were forced to confront the possibility that this was not simply another wandering visitor, but something whose meaning would take years to unravel. The first measure of the new object's magnitude came from brightness data, which indicated a reflected luminosity more akin to that of a mid-sized moon than a cometary body. At first, disbelief ran rampant. No interstellar object of that scale should be drifting quietly into the solar system without producing gravitational effects noticeable long before its discovery. Yet it had slipped into detection range with surprising subtlety, its velocity slightly lower than expected for a body of such size. Theories bloomed overnight. Perhaps it had been decelerated by complex interactions with dust fields or magnetic structures between stars. Perhaps its composition made it unusually dark except in certain wavelengths. The more daring speculations proposed something hollow, something engineered, but no one dared to push that narrative too loudly. What caught everyone's attention was the intentionality suspected in its path. The new object was on a near-perfect intercept course with 3I Atlas. Interstellar bodies passing through the solar system typically follow paths shaped only by gravity and their own ancient momentum. Here, both objects seemed aligned in a way that defied pure chance. The teams analyzing every increment of motion strained to understand the mechanics. Could previous encounters between the two objects outside the solar system have nudged them onto converging paths? Was this a fragment chasing its parent body? Or were they both remnants of some catastrophic event light years away, now drifting together through the void until time and distance separated them? Layers of possibility built upon each other. If they were fragments of a shattered exoplanet, one tiny and the other massive, their reunion within the solar system, even by accident, would offer unmatched insight into planetary formation in distant star systems. If they were once part of a binary system, their arrival could unlock a narrative written across billions of years. Yet the most enticing implication remained that their synchrony might serve as a kind of cosmic message, not one written with intent necessarily, but one encoded by the natural processes of the galaxy itself. The scientific community mobilized with astonishing speed. Every observatory capable of tracking faint, distant objects was tasked with gathering data, while theorists constructed model after model. The object's size complicated everything. At an estimated 100 times the dimensions of 3I Atlas, it dwarfed the interstellar traveler that had already been considered extraordinary. Yet it was drifting along an approach path with such calm regularity that it seemed almost cautious. This slow and steady movement contrasted sharply with the usual frenetic flight of icy interstellar debris. Its pace alone hinted at an age older than the solar system, a wanderer shaped by eons of quiet migration. As the object drew closer, its surface characteristics began to reveal themselves. Unlike Atlas, whose coloration had reflected bluish tones characteristic of volatile-rich materials, the new object bore a muted charcoal gray coating. Its albedo suggested an outer shell that had been battered by cosmic rays for unimaginable spans of time. Yet scattered across the surface were small reflective patches, glints that did not fit naturally with the expected erosion patterns. Researchers debated them passionately. Some insisted they were simply exposed regions of different minerals. Others suspected ice veins. Still others wondered if violent thermal events had once melted sections, leaving behind fused plains. The way it moved added another layer of intrigue. Its rotation was almost non-existent, an incredibly slow drift rather than any active spin. Such stillness pointed toward either internal damping caused by structural uniqueness or an ancient collision that had somehow nullified its angular momentum. Bodies of this size usually tumbled, rolled, or spun, their histories engraved into their rotational rhythms. The absence of that dance suggested an oddly serene past or a series of events so violent they had forced a rare equilibrium. 3I Atlas, by contrast, spun with frenetic unpredictability, as though it had collected every fragment of history still clinging to it. When models showed that the larger object would pass close enough to Atlas that their gravitational fields could temporarily interact, excitement spiked. A near encounter between two interstellar visitors inside our solar system was unprecedented. The gravitational tug could peel away thin layers of dust from Atlas, exposing fresh surfaces. It could shift Atlas's trajectory slightly, revealing clues about its mass distribution. It could even spark faint outgassing from the smaller body. The event promised a scientific harvest that no one had anticipated. The implications stretched far beyond the encounter itself. If two objects were arriving together, the odds that the solar system would see more in the future increased dramatically. These interstellar crossings could be far more common than previously realized, simply faint enough or infrequent enough to slip past older instrumentation. The idea that the solar system might sit along a subtle galactic corridor, one invisible until now, raised profound questions about the cosmic neighborhood. Perhaps the solar system drifted through a region dense with interstellar remnants. Perhaps unseen gravitational influences from the local stellar environment were funneling objects inward. If this were the case, then humanity had only been watching the opening pages of a very long story. The broader public, once the news leaked into general media channels, quickly became fascinated by the idea of a massive, dark interstellar body moving with deliberate slowness toward a meeting with something already alien to the solar system. Popular imagination conjured images of colossal celestial ships or dormant world fragments gliding through the void. While scientists made sure to tamp down the more feverish interpretations, they couldn't completely deny the extraordinary nature of what was happening. The universe rarely delivered a scene so dramatically poised. Particularly mesmerizing was the evolving narrative about the object's origin. Some theorists suggested it had formed in the outer regions of a binary star system long since dismantled by gravitational tides. Others believed it was a lost moon from a rogue planet wandering between star systems. Its mass, still uncertain but undeniably vast, hinted at a structure capable of withstanding deep interstellar cold and cosmic radiation for eons. Its darkened shell may have been a protective mantle formed through slow chemical transformation. Each scenario painted the new object as a traveler from realms far beyond familiar astrophysical processes. Very quickly, the conversation turned to what the encounter would teach humanity about interstellar composition. 3I Atlas had already displayed odd traits, including a mix of volatiles that didn't perfectly match any solar system body. If the larger object shared some of those attributes, it would imply a shared origin or at least a shared type of stellar nursery. If it differed dramatically, then the combined data could reveal an even broader picture. Multiple star systems contributing visitors to the solar system within a short span of cosmic time. The idea that interstellar objects might cluster or arrive in sequences upended earlier assumptions. Instead of random isolated flybys, there might be waves or streams of debris passing through the galaxy. Some of these sequences could be fossils of ancient planetary disruptions. Others could be shaped by the movement of stellar nurseries or the remnants of long-dispersed star clusters. The solar system might simply be drifting through one of these rivers now, its instruments finally advanced enough to notice. As the two objects' trajectories narrowed, simulations shifted to predicting their closest approach. Even though there was no threat to planets or spacecraft, the scale of the interaction drew intense focus. A near pass between two bodies with no shared gravitational history presented a rare opportunity. Their mutual pull could loosen ancient dust from the massive newcomer, revealing surface details that would otherwise remain hidden. Radio studies could detect transient shifts in spin or microvibrations. Light curve analysis might catch subtle changes in surface reflectivity. What made the moment even more thrilling was that the new object's approach provided a natural laboratory for studying long-distance gravitational physics. Large interstellar objects could reveal how unbound wanderers interact with each other when removed from the anchoring structure of a star. No human experiment could replicate such conditions. The universe itself had provided the stage. Even more tantalizing was the possibility that 3I Atlas might be deflected by the encounter in ways that allowed future observation for longer than expected. Interstellar bodies typically slip past the sun and disappear back into the void, their visits brief. But if the new object nudged Atlas even slightly, its trajectory might shift into a path that allowed prolonged study. The scientific payoff from such an extended opportunity would be immeasurable. Beyond the scientific realm, the event stirred a deeper sense of cosmic connectedness. Watching two visitors from unimaginable distances converge within the solar system created a sense of perspective rarely felt. Humanity often imagined itself as alone within a vast, indifferent universe, yet here were two ancient wanderers meeting in the space humanity happened to inhabit. Whether by coincidence or through complex galactic currents, the solar system had become a crossroads for objects older than civilization, older than the planets, older perhaps than the sun itself. The large object's continued approach revealed further mysteries. Its surface, once thought uniformly dark, began to show faint banding patterns when observed through enhanced optical arrays. These bands could indicate differentiated layers from a once heated interior, implying the object might have been geologically active in its distant past. Alternatively, they could be scars left by repeated cosmic collisions. The patterns were too regular to ignore, but too ambiguous to decode immediately. The solar system's magnetic environment responded subtly to the newcomer as well. Sensitive instruments detected minute disturbances in charged particle flow as the object moved through the heliosphere. This wasn't unusual. Any large mass would create minor perturbations, but the magnitude was slightly higher than models predicted. Some speculated that the object had a metallic core that interacted with the solar wind in unexpected ways. Others argued that its size alone generated a stronger than usual shadowing effect. Either way, it became clear that the new arrival was not just a passive rock, but a dynamic participant in the solar environment. As the distance narrowed, light curves from the large object flattened in a way that hinted at geometric regularity, perhaps a broad, stable shape rather than an irregular one. This added fuel to speculative fires, though researchers maintained disciplined restraint. Natural processes could create remarkably symmetrical forms under the right circumstances. Still, the idea that the object might contain internal cavities or chambers formed through natural voids or thermal events led to intense debate. A hollow structure of any size would behave differently during the pass, and simulations began incorporating such possibilities. 3I Atlas continued its tumbling dance, indifferent to the vast bulk approaching it. The smaller object's spin axis shifted slightly as it neared the gravitational influence of the newcomer, a change subtle yet remarkable for what it implied. The interstellar visitors were beginning to sense each other. In those days, data poured in faster than teams could process it. Models updated hourly, sometimes revealing unexpected quirks in motion or surface reflection. New theories bloomed as quickly as they were revised. The excitement felt alive, as though the universe were delivering revelations sentence by sentence. No one knew exactly what the moment of closest approach would reveal. Some hoped for a cascade of dust shedding from Atlas, exposing pristine layers untouched since its birth. Others believed the larger object might experience momentary friction from solar radiation pressure interacting with Atlas's wake, producing measurable flickers. There were speculations, admittedly wild, that the encounter could produce faint electromagnetic emissions as charged particles were redistributed. Even if the interaction passed in silence, its fingerprints would remain in the trajectories, spins, and internal stresses of both objects. The broader implications stretched far into the future. If events like this were truly part of a pattern, humanity might be entering an era in which interstellar visitors became routine subjects of study. Each would carry stories of distant systems, fragmented histories written in minerals and isotopes. Some might be remnants of shattered worlds, some might come from regions rich in organic precursors. Some could even reveal clues about environments where life might develop.